So today we are going to solve some more interesting problems on binary trees. So now what we'll do is we'll try to find height of a binary tree. Okay. So for that, I need to define what is the meaning of height. So the meaning of height is it is the longest root to leaf path. So let me write it here. It is the longest root to leaf path. Okay, so let's take a quick example. Let's say we have 5, 2, 1, 9, and you have 1, 3, and 7. So let me tell you one thing. What is the longest route to leaf path over here? The longest route to leaf path is this one. Correct? Now, some of you are calculating the number of nodes along this path. So number of nodes is 1, 2, 3, and 4. And some of you are calculating the number of edges along this path. So number of edges is 1, 2, and 3. So of course, if number of nodes is n along any path, the number of edges will be n minus 1. So there are different definitions of height. Some people say that height is equal to the number of edges, and some people say height is equal to the number of nodes along that path. So I'll stick to nodes. We will stick to nodes. So for us, height is equal to the number of nodes along the longest route to leaf path. Cool? Okay. Now, given the root of a binary tree, so let's say this is the root and you know about it, you have to write a program that computes the height of the tree. Okay. So that is what we want to do. So what was the most important thing that I told you yesterday? Given a binary tree, if you have to solve a problem on top of it, you have to decompose it into 3 parts: overall root, left subtree, and right subtree. Correct? So any tree that you have to think of it as there is a root which has some left subtree and which has some right subtree. This is your root. Okay. Now tell me one thing. What you want to do is you want to compute the height of this big tree, right? Tell me one thing. If you know the height of this subtree and also the height of this subtree, will it be easy for you to compute the height of this big tree? That is exactly we will do. So let's just take a look. I'll draw this tree here again. So you have 5, 2, 1, 3, 7. And here you have 1 and here you have 9. I can say one thing for sure, that the height of the tree will be something that definitely passes through the root. It definitely passes through the root because you're clearly saying it is a root to leaf path. So the contribution of root will definitely be there. You're counting the number of nodes along the maximum path. So the contribution of root as a node will definitely be there. Now, on the top of that, either the height of this will be taken into account or the height of this will be taken into account. So if you look at this as a separate entity, can you tell me what is the height of this tree? This left subtree, how much height does it have? It has a height of 3 units. And what is the height of this? It has a height of 2 units, correct? Now I would say that, hey, instead of taking a path in this right subtree, I would want to take a path in left subtree. Why? Because the height of this is more than the height of that. Correct? So I would say that, hey, along this thing, if I further include that thing, then my job will be done. So this is the contribution of your root, and this thing is nothing but the height of your left subtree. So I can say that height of the entire tree which is rooted at this root, if I write it in this manner, then this thing is equals to 1 plus, why 1 plus? That is for the contribution of the root. 1 plus maximum of the height of left, comma, height of right. Correct? So height of root left, comma, height of root right. So it means that if I know the height of my left subtree and the height of my right subtree, then I can just figure out the max of those, add 1 to it, and that will be the height of the overall tree. One more thing, any such recurrence relation or equation that you write will have some base cases, will have some edge cases. So can you tell me for what kind of root would you not want to execute this equation or this piece of code? What should be the value of root for which you won't run it? Yeah, when your root is null. When your root is null, then if you do null arrow something, you will end up getting null pointer error. So there has to be a separate case when the root is null. So tell me, if the root is null, then what kind of tree is it? It is an empty tree. And what will be the height of empty tree? 0. Some of you are saying 1, 0. In an empty tree, there are no nodes. So the longest root to leaf path will be 0. So I can say that if my root would be null, I would simply return 0. And for the normal cases, I'll return this. This is how my code would work. Can you all write a function that computes the height now? Can write the code? Yes or no? Easy. It will be extremely easy. So let us just quickly take a look. So let's say I need to get height. This is my height function. It takes the root of some tree or subtree and it returns the height. The first thing that I'll make it do is, if my root is null, that means the subtree that we are talking about is empty. So the height of that will be 0. Otherwise, what I'll do is I'll first compute the height of the left subtree, then I'll compute height of the right subtree. How do you compute the height of left subtree? By just making this recursive call on root left. Okay, so I'll call this function height for root left, and it will supply me an integer. I'll call that integer as left height. Similarly, I'll call this height for the right subtree, and it will give me right height. And now all that I have to do is I have to return 1 plus max of LH comma RH. That's it. Job done. Okay, very good. So what is the time complexity of this code? If there are n nodes in the tree, how much time does it take? See, in reality, what you are doing, no matter which node of the tree you are at, let's say this is a huge tree. No matter which node you are at, if you are at this node, all that you are doing is you are making this call, you are making that call, and you are getting 2 integers from here. Those integers are LH and RH. And with those integers, you are finding their maximum and adding 1 to it. And this is almost constant time operation only. So I can say at each node, you are finding max of 2 integers that is being supplied to you and adding 1 to it. So if there are n nodes, because you are doing constant work at each node, your overall complexity will be order of n. Does that make sense to everyone, that how the time complexity here is order of n? I would also encourage you guys to go ahead and make a recursive tree diagram of this the way I had made it yesterday, and see for yourself that how the values are being returned and how the height is actually being computed. Yeah. What I'll do is, just to help you guys understand it better, I'll draw the recursion tree diagram. So when I look at this function, this is a height function. I'll first call it for the overall root, which is 5. So this has been called. Now, all that you have to do is you have to look at it and you have to figure out how the code control flows. So this thing, it is not null. So this condition will be skipped. You will come here. Coming here means you will invoke the call on the left child of 5. So you will call height function for 2. And here you will call height function for 1. Okay. Now we know how recursion works. You come from here to here. So now you are at this particular node. This particular node again is not null. So you will make a call to the left and right child of 2. The left child is 1. So you will call height of 1. And the right child is 3. So you will call height of 3. So now you will come from here to here. Now again, you are at this node which is not null. So you will make a call to the left and right child of 1. What is the left child of 1? The left child of 1 is null. What is the right child? That is also null. So you will call height for null and height for null. So control came from here to here, here to here, here to here. It very clearly says that if the root is null, return 0. What is the meaning of this line? The meaning of this line is that if you want to compute height of a tree whose root is null, then its height is 0. That's all that it's saying. And here, in reality, you are trying to find the height of this tree, which is 0. That is the reason you should be returning 0 from here. Okay. Now, this call would be made. Again, from here, you will return 0. Now, when height of 1 was called, you made a call to your left child, got 0, made a call to your right child, got 0. And now what will you return? This function will return 1 plus max of 0, 0. 1 plus max of 0, 0 is 1. So it will end up returning 1. And it is correct to return 1 because height of 1 means height of just this much tree. And height of just this much tree is 1 unit. Do you see how values are being returned from the bottommost nodes and how they are being consolidated and how they are being sent upwards? You know, same thing you can keep doing on and on. So height of 2 will now invoke height of 3. So what is this 3? This 3 is not null. So you will call left child and right child of 3. The left child of 3 is 7. So you will call height for 7. And then you will call height for null. Now you are at 7. So again at 7, you will call height for the left child of 7 and height for the right child of 7. So the left child of 7 is null. The right child of 7 is also null. And from null, we return 0. And now what will happen here? Here, you will return 1 plus max of 0, 0. Your left height and right height. So you will return 1. And it makes sense to return 1 because when you look at the tree rooted at 7, its height is 1 unit, correct? Similarly, this is again null. You will return 0 from here. And from here, you will return. Can you tell me what will height of 3 return to its parent? It will return 2. So it will return 1 plus max of left height, right height. Left height is 1, right height is 0. Max of 1, 0 is 1. If you add 1 to it, that is 2. And it is again correct to return 2 because the height of this much part is 2 units. Now again, what will you return from here? 1 plus max of 1, 2, which is 3. So you return 3 from here, which again is correct because when you look at the tree rooted at 2, its height is 3 units. Similarly, can you draw this part like height of 1 calls height of 9, and then can you draw that part on your own? So what will this return? Any ideas on what will height of 1 return? It will return the height of this part, which is 2. And now what will this return? It will return 1 plus max of 3, 2, which is 4. That's how you will get an answer of 4. So again, just to let you know, termination condition is the first part of your code, which you will be writing in your all the problems of trees. And then you call it as calls to LST and RST, or you call it as recurrence relation, which shows that how height of root is dependent upon height of root left and height of root right. If you learn how to craft such kind of equations with appropriate termination conditions, almost all the job is done.